Here's a Riemann sum problem where we have to approximate the area under a curve using table values for that curve. And we're going to be doing the left, right, midpoint, and trapezoid approximations using this table, which has 7 x values and their respective function values. So first we'll start with the left-hand approximation, and since we have 7 x values, we can only do 6 subintervals. So for left-hand approximation, we're going to take the difference in two x values, or delta x, and multiply it by the left-hand function value, or the function value of the lower x value. So for example, for the first term, we'll take the difference between negative 11 and negative 9, and then multiply it by f of negative 11. For the second term, we'll find the difference between negative 9 and negative 2 right here, and then multiply it by f of negative 9. And so on. We can keep doing this for 6 subintervals. Simplify a little, and then see that our left-hand approximation is 34.5. Next we'll do the right-hand approximation, which is again 6 subintervals. And in a similar fashion, we'll be finding the difference between two x values, but instead of using f of negative 11 like we did for the left-hand rule, we'll use the right-hand function value, which is f of negative 9. And we do this again for all 6 subintervals and simplify a little. And then see that our right-hand approximation is 35.5. Midpoint is a little different because we can only use 3 subintervals, as there are only 3 potential midpoint function values that we can use. And the general formula for a midpoint term is going to be b minus a times f of c, where a is less than c is less than b, which basically means we have two midpoints, a and b, and c is just any number in between them. And we're going to be taking the difference between those two endpoints and multiply it by the function value of the midpoint. So for example, let's look at our first term. We're going to find the difference between two endpoints of negative 11 and negative 2, and then multiply it by f of negative 9, because negative 9 is a midpoint between negative 11 and negative 2 in this table. And so for the second term, we have something similar, where negative 2 and 2, we find the difference and multiply it by the function value of the midpoint, negative 0.5. And then the third term is again similar. So we simplify this and see that our midpoint approximation comes out to 38. Lastly is our trapezoid approximation. And here is a general term for our trapezoid approximation, each term, where delta x is the difference between the function values, and then 1/2 times, we can actually average two function values to create the area of a trapezoid. So you can factor out this 1/2 because we're going to be averaging every pair of function values here, so the 1/2 can go out in front. And then for an example, we can see that we find the difference between negative 11 and negative 9 like we have for the past 3 approximations, and then multiply it by the average of f of negative 11 and f of negative 9, which you can see here, and the 1/2 is just out in front. And this goes on, and you can simplify this further and find that our trapezoid approximation is 35.